let's probably wait for 1 more minute. I see the people still joining.
Hello, Eddie.
Hey, Hassan. Yeah, I
Hey,
see a lot of people already. Maybe we can start it.
yeah,
Yeah, you want to start
yeah.
first? Yeah, go ahead.
Yeah, so I have asked Nikhil from my team to actually uh, come and speak about the asynchronous I. Um,
That's good.
yeah, so there is one topic. I'm not sure how much time it's a short set of presentation actually.
That's
Uh,
good.
um, so if the time permits, you have anything else in mind you want to talk about?
If time permit, I have two interns, so I want them to give a report to see what they did in the summer. So then we can closing on the Alibaba Summer of Code, that program.
Sure, sure. Okay, awesome. So yeah, I'll introduce Nikhil. So hello everyone. Nikhil is going to present the asynchronous I. So the status of this work is we did the prototyping, and we in fact, um, we did the scale testing on it, and things are looking good. I mean, we did not see any issues with this. So Nikhil, over to you. Please go ahead.
Yeah. Hi, everyone. Nikhil here. So let me share my screen. So I hope it is visible.
Yeah.
Yeah. Okay. So
Slideshow presentation mode. Yeah, that's right.
so it's still visible, right?
Yeah.
Okay, sure. So hi everyone again. So this is so today we'll go over this asynchronous SI for routing in SONiC. So in current SONiC implementation, what happens is it uses a route bulker mechanism between ARC agent and syncd, but it uses a synchronous one. So basically, OA sends a bulk route request to syncd via the SI redis, and it waits for the ACK before it can send other request. So in this current proposal, what we are proposing is that we'll have a synchronous mechanism where OA will send a bulk request in asynchronous mode to SI redis, and it will maintain a list of some context information, and basically it need not wait all the way for the response immediately from SI. So, and it will maintain a list of this context information. So whenever the response comes asynchronously, we'll process it. So we'll go over in detail in the coming slides. So this is the diagram which basically gives a more detailed look at what is the proposal. So here mainly the changes what we are seeing is inside ARC agent and somewhat in syncd. So in the ARC agent main thread, already the bulker class is there, which will bulk the route entries. So we have introduced this new pending queue to save that context information I was talking about. and then there is a response thread. So this is to process the asynchronous response coming from syncd. So we'll go over detail in this implementation in the in somewhat detail in the individual changes what are being done. So with respect to route org will send the bulk add, update, delete messages like it is currently doing. So with that, with each bulk message sent, we'll save a list of prefix and VRF context information, and this is preserved in the something called as ACK buffer. So this ACK buffer, it will be added to a queue, pending queue basically, and it has the it will have the route prefixes in the same order in which the initial bulk request is sent. So, and there we have put a limit like how many bulk messages can be sent to syncd before it gets a response for the first one. So we can like tune that limit to like how many pending messages we can keep in the queue based on that. And once we reach that limit, uh, basically OA will not process any more request and not send any more bulk request. It will basically keep the routes in the M2 sync queue. So yeah, maybe I will go over this next 3 slides which explain the changes. Then I can open for questions.
Mhm.
Or if someone has question, you can ask in the middle also. From syncd side, the changes are like syncd will process the bulk message. It will call the bulk SI API and get the response for the configuration message, and the response is sent back to OA using a notification producer class. So this is a SI, I mean the Redis way of sending the notification back to the org agent. And so the response thread. So basically to have a parallel processing between the information being processed by route org and being sent to SI, and getting processing the response. To parallelize this thing, we have introduced a new response thread for this task. So what will happen is whenever the bulk ACK message is received from syncd, it is received using the notification consumer, which is again a Redis class for implementing the ACK, listening to ACK, and it will match the bulk ACK with the bulk route request which were sent. So to match it, it will have that pending queue. Basically, it will pull out the topmost entry from the pending queue, and it will match the ACK with the response whatever is received. And to implement this, we have used a shared the pending ACK queue is a shared data structure between the OA main thread and the this newly introduced response thread, and we use the mutex to separate, basically to say to have a safe data structure between the 2 threads. And we have added some improvement like some improvement on the sharing in a way that say initially there are like 5 bulk pending messages in the queue, and now the first response is received from syncd. So what will happen is this whole 5 pending queue of this 5, the ownership will be transferred to the response thread, and it will create a new queue for the main thread to write, so that the mutex operation will happen only when this particular pending queue of 5 is exhausted. So ACK NACs are so with this, basically the ACKs are processed in parallel with the org agent main thread, and based on that we can write the route operation in the app state DB for further applications to make use of it.
Can you explain a little bit like this for the mutex log, like say when you want to use it? I come to little confused here.
Yeah, sure. So
you are doing that, it's like a per prefix or is it per bulk?
No, this is a per bulk. Let me go back to the diagram. So basically, route org will the bulker will basically take the routes, individual routes from route torque, and it will create one bulk request. So when we write this bulk request into SI Redis, at the same time we save this context information with prefix and VRFs information, and we create one bulk entry, and this bulk entry is pushed into this queue. So this is the one when the mutex operation mutex is acquired by the main thread, and say we'll have this n number of entries in the pending queue, and now one response comes from the syncd. So whenever this response comes, what will happen is it will take this whole queue and give the ownership to the response thread, and for that it will again acquire the mutex, and as soon as the ownership is transferred to the response thread, the mutex will be released. So basically the OA main thread can now come in, and it will create another basically another pending queue. Empty pending queue is already created, and OA can write into that pending queue for remaining requests. And what will happen is as soon as the responses keep coming from syncd, so this pending queue which already had say 5 entries, it will basically get exhausted. Once that is completely exhausted, then again it will acquire the remaining pending queue from the org agent main thread.
Your bulk is basically because there are two threads. One thread is writing to the pending queue, other thread is retrieving from the pending queue. So you want to make sure
right,
avoiding the conflict. Okay, gotcha.
Right, but just little optimization on top of it, so that main thread is not completely like continuously starved for the mutex basically.
Okay.
The starvation, to avoid that starvation, you said the limit is five entries, or
no, so like the limit we can set based on how many entries we can keep, but I mean how many, like it's a threshold which we want to maintain. Like we don't want to overload the syncd with too many bulk requests, pending bulk requests. So that's why we kind of threshold it using this count in this queue, and basically as soon as we receive the ACK request, then further OA can process. And this this we can tune this number. It's not like fixed number.
So basically the bulk SI Redis calls, there is no limit that can go as is. But along with it, you're also actually queuing up at the pending queue. And as and when the syncd starts giving the responses for the one of the bulk requests, the response thread should not be it should not wait for the lock to get released to be able to acquire to acquire anything on the pending queue and start processing, right? So that's where a little bit confusion is there. Probably I missed something in between. Yeah.
No. So it will acquire the lock basically, but once it acquires the lock, what will happen is it will transfer the whole pending queue to response thread. The ownership, like all the entries, will now belong to the response thread, because OA main thread it doesn't have to do anything with the already existing entries. So, and it will create an empty queue for the further request. So now once it releases the response thread, it releases the lock, it can process the pending entries in its own context as soon as the response comes from syncd. And OA main thread it can acquire the mutex and keep adding entry in the new pending queue basically. So basically the OA main thread, OA response thread is not tracking the mutex too many times. Like say there are 5 entries already in the pending queue, so it will take it only once and take the whole ownership, and OA main thread will take it each time while adding every entry into the pending queue, so that the starvation of main thread is avoided here.
Okay.
So Nikhil, only the brief period of time.
Venkat, one question here. So regarding the size, you said it can be tuned, right? How is that kind of? Is it through some configuration variable, or maybe is it something we can hard code and then change it based on what is the performance?
Yeah, right now actually it is a hard-coded value which we have kept it, and we can basically tune it based on performance.
Okay. Another question is there a configuration knob to switch between the synchronous versus asynchronous mechanism?
No, I think there is no configuration, but there is the invocation of the Dockers. Basically, Docker init has the parameters where it passes those options, whether it wants in the sync mode or in the async mode.
Okay, by default, are we changing to asynchronous mode, or are we keeping the synchronous mode as such?
Yeah, for this we will like by default based on what is the requirement for performance, we'll either keep it in async mode or sync mode.
Yeah,
No,
I think
in this
Sudarshan,
implementation it is in async mode.
yeah, let me answer that question, Sudarshan. So actually, this is a proposal. We are presenting it here, and then this will go as part of the HLD that Eddie and his team, right? Now that HLD will go for the review in the bigger forum. So once that is approved, we will actually push for enabling the async mode by default.
I see, makes sense.
Yeah.
And apart from that, we also have, like, once the route is installed, there are certain operations that are being done, right? For example, if there is a failure, we will have a handle status failure, and then there is a crash, and then we also increment the CRM counters, etc. So all this will be now moved to the response thread.
No, so this is the starting point. We are doing it only for the route as of now. The remaining operations, because those are not that heavy, they will continue to be synchronous.
So if I understand, then the CRM will be updated immediately after we do the create route or something, right? Then it may not reflect the actual state until the route is installed.
So CRM also was integrated, Nikhil. Do you remember? I think there were a few changes required to actually update the counters. Do you have the details captured here?
No, I'm afraid those are not captured actually. So yeah, some part of CRM, we had some implementation, we would send a message to CRM from the response thread, and for the route processing, and the counters will be managed based on this messages.
Okay. And what about the failure handling? In case if the SINCD returns some kind of failure, will we be doing the same, like Arc agent about same as what in the synchronous mode?
Yes,
the failure handling then.
Yeah, the failure handling will be done by response thread in this case. Yes, Hassan, sorry. Please add on.
No, I was just trying to say that I think for the failures, we anyway have another PR for the suppress route suppress pending, right? I don't think that the failure should actually crash the Arc agent. It should be just indicated to the application that this route could not be installed.
Yeah, but today I think like a lot of the SI failures are kind of handled through handle size status failure. So let it be even without crashing the Arc agent, right? I just want to understand whether do we have a corresponding behavior achieved, like the synchronous versus asynchronous will result in the same failure handling, right? So just wanted to ensure that.
Yeah. So I think there were two models. One was I think there was a proposal for the error DB that any errors actually should be pushed into the error DB. Right. Whereas if you look at the suppress FIP pending PR, that is introducing another table that is app state table, where all of the statuses of the prefixes will be stored. And that state DB is actually fed into or read by the listened to by the FPM SINCD, which actually sends these responses back to the Zebra, and Zebra actually sends it to the BGP. So that channel will be plugged in with this.
Okay. Yeah. Do we have like any kind of numbers between like synchronous versus asynchronous? That would be really great to push for the asynchronous mode, right?
Yeah, I think Eddie, did you collect that number because you disabled the synchronous mode, right?
right now we are in the occasion just still in the synchronous mode, right? So we are not really changing this asynchronous. So, but we increasing the bulk size. I probably like, Shui, you want to comment more on that?
Actually, we used the async mode.
Okay.
Yeah, this is what I remember from previous calls, Eddie,
Yeah.
it double the synchronous mode.
Yeah, I would recommend having those numbers before taking to the community so that we will have some data to push for the fact that we need to have asynchronous by default to have a better performance.
Yeah, I think before any of these optimizations and on top of the optimization, we can merge, club all these changes, and then because Eddie, the numbers that you were that you were showing in the previous presentations, that will not be the correct numbers the moment you enable the synchronous mode.
Okay. But then
Right.
let me ask you one question. It's like I say, what's the motivation behind the two changes? It's basically we want to get the arrow back all the way to the BGP, or we want to speed up the between the ARC agent and the CVD because you change to the asynchronous mode.
So I think this frees up the ARC agent rather than waiting for route to get installed, right? Even today with the synchronous mode, we get the route all the way back to BGP if you have the suppress with pending. But what happens is ARC agent need to wait for all the, if it calls like 1,000 routes, it needs to wait until the 1,000 routes are installed. But now you can just call and go back and do some other operation, which significantly improves the boot performance time, etc.
Right.
Yeah, at least the single thread, right? It's like every other agents also waiting. So if one thread asks the, for this route operation, then other unnecessarily waiting. So this will definitely free up that, programming time so that other get a fair chance. So
basically,
helps.
routes downloading may not be improved that significantly because SYNCD is still busy, but you give the space to other features.
Right.
Okay. But what the SYNCD itself is be able to pick up those.
No, Eddie, actually. So even if you look at, say, the route, right, you're just doing, say, route install testing, right? Even in there, any time which is given back to ARC agent, it will use it for, say, computation or dequeuing from the M2 sync and processing the route.
Okay.
So the other one, the application state DB, right? Today we with the synchronous, we just program and report an error. Let's say you don't need FIP suppress related. You don't need to notify the route errors to the BGP. In that case, we simply send it to the syslog and that's it. That's about it, right? But with this one, we are introducing another copy of routes in additional application state DB. Is that really optional thing, or we are going to mandate it?
No, so there is already, I think all those changes are already merged as part of the other PR that I was referring to.
Right, but is this application state DB you refer for the PIP suppress announcement or which one?
That's right. So it is actually for the suppress FIP pending. Let me put this PR in the chat window.
Yeah, I know that PR, but is that enabled by default or like
I don't think so, but this mechanism can be used irrespective of suppress pending too, right?
Yeah. What I'm saying is, PIP suppress announcement is, if at all we really need to, redistribute the routes from one node to another after hardware programming successfully, right? If let's say, some, node that does not care about it, we would end up putting this another copy of the routes in application state DB. That's what I'm saying. So is there
yeah,
I mean, we already maintain a lot of route copies in multiple DBs today. I just wanted to see whether is one more maintaining this copy makes sense for some scenarios, but not sure if that copies is required for every scenario.
Yeah. So I think we can latch on to the existing knobs.
Okay.
Because the state DB that has been introduced is actually only for the suppress FIP pending, right? So
yeah.
Yeah, we will integrate with the same flow. And if, say, the state DB has to be written only if the suppress event pending and enabled, then we'll do only that, right? So I think it's just the integration part. Yeah.
Yeah.
So
the one
so
more
why
question.
can't- Yeah, why can't we do it without the suppress pending this feature? I think we can also integrate it in such a way that it works in a normal flow, right?
No, I think the question was very specific to the state DB that
No,
Yeah.
not state DB. I believe in general, this can be a feature that can work with or without the suppress fit pending,
correct. Exactly.
Okay,
What I was
just
referring,
wanted to clarify that. Yeah.
What I was referring to was that what to do with the responses, right? One way is to
Yeah.
just log it, another is to actually push into the state DB.
Yeah, makes sense.
So the Hasan, with respect to, when we program the route, we depend on the next hop or next hop groups, right? How are we dealing with those dependencies? Like from Arc agent, we create the next hop and we construct the message for route and associate route with the next hop or next hop group, and then push it to the SYNCD. Today, if you bulk it and there is a dependency on the next hop group, how are we making sure that dependency is first executed and then followed by the dependent routes?
So I think today what happens is we go over the next stops and then install them first before creating a bulk route. That's how we do it today, right?
Right.
And
so we'll my question is, do we wait for the response of that next stop?
Yeah. So Venkat, actually, this is not reordering anything between the org agent and SYNCD, right?
Okay.
So whatever order the next hop and the route had to go, it's just going just that for the route, we are not waiting for the act.
Okay.
Yeah.
All right.
So Hasan, just to clarify, this mechanism of asynchronous is only for the route object programming or even for the next object, next hop we are going to follow?
It's only for the route because next hops are not.
Okay. Yeah, in that case, it makes sense. It's not going to have an impact.
Yeah, so basically the next hop will still be synchronous.
The same flow, yeah.
Okay, yeah, okay.
Yeah. Okay, so I think only one point is remaining here. So there are like certain assumptions we will be making for this thing to work, like SYNCD.
I think
Yes,
there
sorry.
was the SYNCD slide, right?
Yeah, we covered that actually already.
Okay.
Yeah. So so with respect to SYNCD, there will be some assumptions like SYNCD has to respond, send a status response for every request, bulk request. And SYNCD SI preserves the order in the response. Basically, the order of prefixes within the bulk request should be maintained across the request and the response message. And the order in which the response is received for each bulk message, that also needs to be maintained by SYNCD. So that is one. These are some assumptions which are made here. So yeah, other than that, do we have any other questions?
So what's the relationship between this side change and the fifth suppress announced that the PR, because that PR is already merged. So this is more like the enhancement on purpose for that PR, or?
Yeah. So Eddie, as we were just now talking about that, right? That what to do with the responses which are coming back, right? So there are two choices. One is to just log it, another is to actually push it to the state app DB. And state app DB has been introduced by the PR that I was referring to.
Okay.
Yeah.
But your PR, the PR which you refer to already merged in the SONiC, right? But this proposal is not yet, right?
Correct. This is not there yet. Yes.
Okay. So what currently what you did is that you get the response back, but this is the sync mode. So you want to change it to the async mode to speed up. Is that understanding, or?
Yeah, that's right.
Okay. Then how do you determine the size and those things? It's based on like it's kind of like the bulk size. So
yeah. So I think we did some testing, some stress testing to see that how many rather what is the max outstanding queue size that grows to, and then it shrinks back, right, back to zero. If I'm not wrong, Nikhil, you can correct me. I think that number was somewhat 20. So in the stress, actually, that outstanding queue size was going up to 20 and then shrinking back. So maybe we can set, that number somewhere around that.
Yeah, right, Hassan. And the thing is, regarding the bulk request size, I think there is some time slice which is given in org agent. So based on that time slice, how many entries can be pulled from the M2Sync queue and processed by org agent route org? Based on that, it will like that number will vary basically.
Right, and it makes sense to actually. So this can work as a back pressure. So suppose SINCD is slow, depending on the platform, or and say the application is able to push the routes at a lot faster. In that case, the total number of routes may be just limited, maybe just say 1 million, right? But the updates that might be coming in may run into multiples. I mean, there might be 1 million times n, right? These updates, because the routes may be flapping. So if you have the back pressure coming in from the SINCD, then all those routes can be, collected in the M2Sync itself if you're not draining it from there.
I see. So you basically want to, but this is for back pressure part, right? Basically, you say, hey, I don't want so many outstanding requests, so someone slow down.
Exactly. So it is not going to back pressure the application. It will just, the routes will be just updated in the M2Sync itself, because that is actually a hash.
But then I probably want to see that normally for the routes insertion fail, because what kind of fail you see besides the size? Because for me, besides I run out of the hardware space, I never see that the route insertion fail. But then the second one is what's your expectation if the route insertion fails? Do you expect someone handling it as the admin and handling all? I want to see what kind of the operation you want to expect after the failure.
Yeah, so I think this question is actually getting into the suppress pending area, right? So you're right that majority of the time the route installation may fail only because of the table overflow. But you never know, right? We have seen, depending on the prefix, say the next hop also can play a role. For example, next hop table overflow, not the route table, but somebody was injecting with unique next hop and next hop table overflowed, or they were not deleting it actually. So it could be any kind of anomaly, which may result into this failure, but this response has to be given back somewhere.
I see. Okay.
So was this feature Wormboot compatible? Was this tested with Wormboot?
Yes, we did test with Wormboot.
Okay.
Yeah, thanks, Nicole. I think that's pretty much, we can move on to the next topic.
Thanks,
Sure.
Nikhil, did we simulate the table full issues and all that, and how are we pushing it to the application state DB? Did we test all that?
Yeah, I mean, we did basically on the platform, excuse me. Yeah, so we did test with the on a platform where the scale was not really supported, and we did bombard with more routes than they were supported, and we did see the table full errors in the state DB, in the app state DB.
Okay. If you could dump some of those errors being present in that application state view, that would be helpful. I mean, just put how you are displaying that information.
Sure, we'll do that.
So Hassan, this one need to have the side change, right? So if we really want to push this one, we need to go to the side, like a weekly meeting to present this change in side API, right?
So the SAI response is already coming back, actually. The changes that were required were only in the SING-D. So no SAI spec change.
Okay.
Yeah.
Gotcha. Thanks.
Yeah.
Good.
Yeah,
Cool.
Thanks.
So,
Okay.
maybe
Thanks.
Hassan, now you can uploading this slide to our
Yeah. Yeah, we'll do that.
Yeah.
Sure. Yeah, let me stop sharing.
Yeah, thanks. Yeah. So
Thanks.
at the beginning of this summer, we have like Alba has a summer of code the program, which is coached by Donna and Jeff. So now time passed fast. It's already August 31st. It's we are at the end of the summer. So we have 5 interns in this program. 3 of them already presented before. So we have 2 more to be presented today to closing their programs. So that now they can go back to school and to go back to their normal life. But it's a really good experience. They have very good summer to learn the FRR and to hands-on and raise the PR or merge the code. So I want, like I said, the last 2 interns to present today, so to show what they did in the summer. So let's start with the Hongyu. You want to start first?
Yeah. Can I say it?
Yeah.
Hello everyone, I'm Hongyu, an intern from Alibaba. I'm going to introduce my summer code program, which is adding a new data plan using port buff. In FRR, adding a new data type in NetLink is hard because it's not easy to modify Linux files. And if the new feature date doesn't need support from Linux kernel, using NetLink format may cause a lot of unnecessary overhead. So NetLink format is too complex. And the solution is to add a new data plan using port buff, IPMPB. IPMPB is a separate data plan module. It can easily set some customized data types. IPMPB can work in parallel with IPMNL. You can transfer custom data with IPMPB and original data with IPMNL. Here is my code commits. These are new data channel in Zebra, socket server side program, and test case in top test. The bottom is my PR link. Here is the stage where the data is processed. It's divided into 3 parts. In the first part, data plan will get data from Zebra and put them in a context queue. In the second part, it will process every single context, add FPM header after generating payload, then write the data to buffer, ready to be sent. The third part parses the data and package it into binary using port buff. And the data plan server program. It's a server-side socket program. It uses the same port file as data plan FPMPB. It could receive data from data plan and parse it into JSON format. Then output it to the specifier. the output as show is shown as a figure. And I added a new top test case, Zebra FMPB. It built a topology and start a data server in router, send route and preset ref JSON. The data plan server will parse the route and send it to output JSON. Finally, we can compare output JSON and ref JSON. If they are the same, means test pass. And the result is shown as a figure. That's all. Thanks, everyone.
Good. Thanks, Hong.
So yeah, Eddie, this was intended for the SRv6 routes, right? I mean, now we tested unit tested with the regular routes, but eventually we will be using the protobuf for SRv6 routes, correct?
No, for the policies, right? For the policy
correct.
and like Mike said, those kind of things which I don't want to hand on the kernel.
Correct.
Yeah.
Oh, okay.
So will there be 2 sockets right now, or we are just using 1 socket and we may send the netlink as well as protobuf?
Yes, we can. There has 2 sockets now, and we can send some custom data by with APM protobuf, and send other data with APM. It can it can I can set their priority. If the APM protobuf had higher priority, it can first process data and send some and send the chosen data. The APM can send the left data like this.
Okay, so you're saying that the existing messages will flow over the netlink socket, and the new messages will use the protobuf. But yeah, I mean, I was just thinking that having 2 sockets may cause some race issues. Yeah, why not actually move everything to the protobuf? Eddie, what is your thought on it?
Actually, that's a good discussion. Like I say, initially we are also debating that the back and forth either 1 socket or 2 socket, and the thinking is like I say, we try to avoid touching the netlink channel. So then this one can be add on independently. That's why later on the team decide to do with the 2 socket. And from the basically say the timing point of view, since it's I feel it's okay because you are coming from the same thread, so and both will be the sync sending. So basically, then you don't really get involved with the 2 sync the issue, right?
No, but processing side, you can actually have the reordering, right? Depending on actually
yeah, process depend on how we handle it. If you put in the file descriptor, like say round robin base, then you can still like maintain the order, right? So it's really depend. So that's why I would say like it's probably just a 2 socket. It may not be that good, but it won't causing the problems. But the benefit of a 2 socket is more like say the clean. So we can easily to say, for example, some people don't want to using this protobuf, then it's just the independent library to be removed. So it's kind of the clean cut. That's the one reason.
Yeah, I mean, I would prefer personally that there is only 1 socket, and we have a choice to use the protobuf. If somebody want to use and completely migrate and use only the protobuf, including for the existing messages as well.
Yeah. So that's a remember like initially with the discussion to see we may want to like for we may for SONiC at least we may want to like move everything to with the protobuf, right? If we open that door. So then for the FR they need to keep that because they still have a lot of people don't using
Yeah.
this one. That's why I
Yeah.
don't want to mess up that link.
Yeah, I would say this can be a starting point, and then eventually we can migrate everything to that to this.
That's true. Yeah.
Okay.
Why last time I persuaded like the Kentaro, right, to say the next group should we go in this direction? But that's we can discuss it.
Oh, you mean to say whether next top group should we use the netlink or so for next top group we already have those new next top, yeah, these netlink messages, right?
That's true. That's true. Yeah.
Yeah, but as we were saying that I think if you're using next top group, if you're using protobuf for next top group, I think better to actually use that for route as well, because otherwise you will have the reordering problems.
That's true. That's true. Yeah. If I use it like put it in the net, because this one you see that I put right now we only do the SRv6, so it kind of like a silo, so they can come anyway in different orders. But
And
the moment
exactly.
I do the net link, then I have to keep in the same order. So then it's a hard requirement.
Yeah.
Yeah, I would say as long as we send the auxiliary data over it, it's kind of okay. As I said, it's silent. If we start affecting reachability, I think we are a long time before ordering reconciliation of data should be considered. Yes. Yeah, I think we are really far from doing this over our protobuf.
Agree. Yeah. So I will probably like checking out to stay where we are. So we only add this as a silo to pushing some additional ones. Good. Any further questions? Okay, thanks, Hong. Then we take the last one is a Wenbo. Yeah, when you want to start sharing.
Can you see me screen?
Yeah.
Okay, let me start. Okay, hello, I'm Wenbo. I'm working as intern for Alibaba now. I want to introduce my summer intern project with FR community. It is kernel bypass route map and deep plan test simulator. So that's all. So first, I talk about kernel bypass route map. As we know, Zebra have two paths to deliver routes. One is from Zebra to kernel by netlink, and another one from Zebra to FPM syncd, and finally goes to ASIC by FPM. So one route will send to kernel and FPM syncd both. And in some scenarios, there is no need to install routes to the kernel for software forwarding. And I design a route map provide ability for user to bypass this install. So the route map be like you can set kernel bypass and user define match statements. When match statement satisfies, Zebra will mark this route and once install marked routes to kernel. And to maintain consistency, when the new marked routes operation is updated, it will check if there is a same prefix old route and delete it. So it is for a scenario that the route map is configured after Zebra initiate, and the route will install in the kernel before, so I have to delete it. So I also tested the efficiency. The route map will bring match overhead, but it is acceptable because it is up to user if he want to use it. Also, kernel bypass will reduce a lot of time because it will bypass the root install in kernel. First, I do a experiment. I use test engine set 500,000 BGP route to device, and I can see orange byte time like 18 seconds. Also, I want to say this is only contain the time spent by Zebra to IPM SYNC-D, not include about the SONiC SWSS time, which means the radius, write and read. So it is a flame graph. You can see the function call stack is very deep. after I set the route map, as I can see, the install time is reduced to 9 seconds. It is 50% reduced. Also, I develop a test simulator, which means FR community lacks testing methods for the chip distribution channel, which means the IPM SYNC-D to ASIC, this path is no unit test method, because the receiver IPM SYNC-D is in SONiC community, as we know. So I need to support it. There is a few challenge. Support for multiple protocol types for route passing, because the EVPN and IPv6 routes is different. And I need to write clean code because the SONiC license is not compatible with FR. SONiC license is Apache 2. Also, I want to provide a universal testing interface to make route distribution more readable. So it is first we replace IPM SYNC-D with a simulator to receive and process messages, as I can see from this figure. And difference analysis methods are used for various types of routes. For example, EVPN routes need to analyze RMAC and VNI fields. And as last, I store routing information as a readable JSON file. It is similar with Hongyu's deep plan test server, because his deep plan test server will take responsibility for pass protobuf route message, and my simulator is to pass netlink route message, and we will combine the two simulator, or means test server together, and together it is a teamwork. So that's all. I provide unitize for this both work, and create PR to FR community. It is under review now. Thank you.
Thanks, Mumbo.
See, if you do the kernel bypass on the fly, right, do you basically remove the routes that are installed in the kernel, or what do you do?
I do when in Zebra, I check the marked routes. It is like a flag. Once flag is satisfied, I return a success. Yes, I return a like FR netlink success. I remember the macro name. Yes, in kernel update, is the function. The function name is.
Okay, basically what I'm saying is the routes are already installed in the kernel, and I want to bypass as a second step. I want to bypass those routes, right? So because it's already installed in the kernel, you are going to remove it. Similarly, if you remove that kernel bypass from route map, you are going to add back those routes removed from the kernel. So I mean, I believe those cases were also handled, right?
Yes, because when we remove the route map, the configuration is changed. So there is a configuration named software configuration inbound. I think when this config is set, the route map is changed and the config is changed. So all the routes will goes to the Zebra again.
Okay.
Okay.
Yeah, sounds good. Thank you.
Could you please go back to CLI?
Which slide?
It was second slide, I believe.
Second.
No. Next one. Next one. Yeah, this one. No, go back. No, one back. Yeah, this one. So probably in sets you would like to use single keyword, because otherwise, I mean, you would need to provide the auto-completion. So just do set kernel dash bypass, for example. Make sure it's a single word.
Which I don't get you mean. What was it with a single word?
I think the route map name.
Route map when you set matching parameters.
Match
It would make sense
parameters.
to use single word, not two words.
Kernel hyphen bypass, Jeff. That's what you mean?
Yep. Yeah.
Okay. Okay.
Second, in matching, you would really like to define what could be matched upon. So it could be only protocol type and destinations, right? So it needs to be documented practically. Would be also good to throw some error if someone else is trying to configure something different than protocol source. So let's say BGP or service 6 or something that's not prefix list. Imagine someone puts an IS pass filter in there, right? So make sure it's usable and documented.
Maybe do you mean the route map should be related to the protocol like BGP or kernel, the route type?
Yeah, because RIB knows the source, right? So
okay,
that would be the easiest one. So if you want to match on all the service 6 routes, you don't need to build a prefix list that has all of them. You just need to provide source of the protocol you would like to be bypassed by kernel. That would be the most useful match parameter.
Okay, I can handle this question. Just as we know, just the Zebra has a route map, and if we want to use this route map, I have to mount the route map to points like address family. Yes, this is in BGPD. And if we want to use route map in Zebra, there is a like IP protocol, and you specify the protocol.
Yeah.
I think this can handle the protocol route type. Yes.
Yeah. So again, logically, the best matching parameter here would be protocol.
Mm-hmm.
So you don't need to try to figure out what you're matching upon in terms of routes or prefix list, but you just say, I want all the routes from a service 6 or ISIS to be filtered, right? That would make sense from configuration perspective and modeling perspective.
Mm-hmm.
Okay.
Yeah.
So that's all on my side. Thank you.
Thanks. Any further question? Good.
So Eddie, I think in the HLD, when we write an HLD for this feature, I believe we should mention that, because today the kernel is doing the ARP resolution and all that, right? For
yes,
somehow the routes, that we need to put it to the kernel. So somehow the routes we don't need to put it to the kernel. With the user should consciously make that decision here. So they should not randomly put it here, so things won't work. So we just need to put it at the things in the HLD.
So me again, I'm sorry. So the configuration here is kind of ambiguous because you don't show the IP protocol part of it, right? It's going to be a IP protocol, source, and then route map. So in future presentations, then you don't need to mention protocol, really, because protocol is kind of provided before. It's route maps that applies to particular protocol.
Yes, is what I mentioned before.
So please change the example so it's clean and clear how it's going to work.
Okay. Sorry.
Yeah. Good. Thanks. Yeah. So this is basically the conclusion part for the summer intern program. So probably next year, like Jeff, Donna is not here today, but let's do it again. Coaching some young kids to do the job.
So Eddie, do we have an update on the next up group? Did we talk about it earlier or not yet? Or it's in the pipeline? You want to discuss? Where are we on the next up group?
I don't see Kantara is here, so let me ping him. Yeah, let him to bring in. So we haven't started talking about it, but next week I want to continue the talk from the mic to see that how we do the BGP picks. But then once we go in BGP picks, actually we need to do the next hop group. So that's kind of like hand in hand eventually.
Okay.
Yeah, so next week we started talking about I want Hanyu to start to give an initial draft proposal, so to see, but this is a very early draft. We probably need to discuss a couple of rounds to finalizing it before we can write in the HOD. Yeah. Then the HOD, like I say, the loading time in the HOD right now, I think Hassan, Venkat, you guys are cooking it right now. So once we get to the stage, maybe like 2 weeks from now or 3 weeks from now, let's talk about it in this group. Then I'll pin Kantara to see that where he is on the big part, but he's waiting for us also. Good. Good. That's for just for this week. So next week we start probably the fix journal again. Yeah. Okay. Thanks everyone. Yeah. Bye.
All right. Thank you.
Thank you.
Bye.
Thanks everyone. Bye bye.
Thank you.
Bye.